All right, starting the no calculator section. So everything we got to do here is mentally. It's not really as much for arithmetic, but more for like graphs. They want to know if you can do graphs and transform graphs in your head without using a graphing calculator. So number one, 51 equals 7 plus 2x. Question is, what value of x satisfies the equation? So this is just going to be a good old-fashioned two-step and solve. So I'm trying to isolate x, trying to get the x term by itself. So I want to get this term right here alone. So I'm going to subtract the 7 from both sides. And that gives me 44 equals 2x. And then the opposite of multiply is divide. So I'm going to divide both sides by 2, which gives me an answer of x equals 22. So I believe the correct answer is D. An alternative method, if your algebra is not so good, which I definitely suggest you brush up on it and get good at it, but if you're not, another way you could do is you could plug answers in. So for instance, you could just take 58 and plug it in for x, and you'd have 51 equals 7 plus 2 times 58. And when you multiplied this out, you would have a false statement. 51 equals 7 plus 116, which would come out to be 51 equals 123, which is not true. So it does not satisfy the equation. So this one would be out. And then I would move on down the road. I find that a lot of problems where you can plug numbers back in, the real answer tends to be towards the bottom because they know most kids start at the top. So some problems I do plug answers in, and you'll see me do this later in this section. If I am going to do that, I'm usually a little more strategic. Sometimes I'll start with either B or C, and that way if I'm too big or too small, I kind of know which direction to go and I don't have to try all the answers. So just a little tip there if you're going to plug numbers in. Number 2, I have an equation up there. 3a plus 4b is 25. I need to figure out what the heck a and b are to substitute in here. But it says a shipping company charged a customer $25 to ship some small boxes and large boxes. So this is what we're dealing with. 2 different size boxes. The equation above represents the relationship between A, which is the small boxes, so A is the small boxes, and B, which are the large boxes. And it says the customer had shipped, if the customer had 3 small boxes shipped, so we know that. We know there are 3 small boxes. And then the question is, how many large boxes? So that's what we're after. We're after B. So basically, it looks like we need to plug in A equals 3, because 3 represented the small boxes, and then we need to find the letter B. So we take our equation and we say 3, and instead of writing A, I know that there were 3 small boxes, plus 4 of the large boxes equals 25, and then I'm going to kind of multiply this out, and 3 times 3 is 9, plus 4B equals 25. And now I have 2 steps left. To get B all alone, I'm going to minus that 9 from both sides, which gives me 4B equals 16. And then divide by 4, divide by 4. That's a pretty bad looking B, but B equals 4. So 4 of the large boxes were shipped. So the correct answer here would be B. All right, number 3. On January 1st, 2015, a city's minimum hourly wage was $9.25. So we're starting out at $9.25. It will increase, so that's a key word. That means it's going to go up by, we're going to add to it. It's going to increase by 50 cents on the first day of the year over the next 5 years. Which of the following functions best models the minimum hourly wage in dollars X years after 2015. So it goes up 50 cents per year pretty much. So we start off at $9.25. We are going to increase or add 50 cents multiplied by every year, which they're using the letter X, and that should give me the final amount. That should give me how much the hourly wage is. So it looks like the correct answer here would be C. The only thing you got to be careful on, these two right here both represent decreases if our hourly wage was going down. So right away I can scratch those out because you're subtracting. And then if you accidentally chose D, I mean, that would be if you were starting at 50 cents and you were increasing by $9.25 a year. So your salary or your wage would go up very quickly. You can also think about this in terms of a graph. If we were talking about graphing and we had your years on the bottom and we had the money you made on the side, if you start off in the year 2015 or at x equals 0, we'd be at $9.25. And then if you think about every year after that, so at x equals 1, right here, we're going to go up 50 cents, and you'd now be at $9.75. After year 2, you'd now be up over here another 50 cents, that'd be $10.25, and so on and so forth. So it's a linear function, and the slope is your rate of change. All right, so the slope is actually what you are increasing by, and you're increasing by 50 cents. So I really want to drive home that point of slope being a rate of change. And if it's positive slope, it's an increase. And if it's a negative slope, it's a decrease. That's going to serve us well when we move into the official practice tests. All right, number 4 looks like we have an equation. Looks linear. I don't see any powers or squares or cubes or anything. So it looks like it's a line. In the equation above, F represents the total amount of money in dollars a food truck charges. The key parts here that we need to see are what X and Y are. Well, X is the drinks, and Y represents salads. So let me kind of write this out here. The food truck brings in 2.50 times X, which is the drinks, plus 7.00 times Y, which represents the salads. So we're talking money here. So it looks like it's $2.50 per drink. And then $7 per salad, or multiplied by however many salads are bought. So what does the actual question say? And I always kind of like to go and circle that or underline it, because usually when I miss problems on the SAT, it doesn't have anything to do with math. It usually has more to do with I misread the question. Which of the following is the best interpretation for the number 7? Well, 7 was the dollars per salad. So the price in dollars of one salad. So be careful. It's not the number of salads. That might be another option that some people might choose. It's not that one. It would be the dollars per salad. All right, number 5, looks like we have a graph here that we need to interpret. I always kind of very quickly look at a few things. Number 1, I like to look at what the axes, how they're labeled. So it looks like we have elevation on the bottom here, how far above sea level, and then we have the plant diversity is over here on the side. So I kind of want to know which number represents what. One thing I also look at too is I look at the scale. So I notice that on the bottom, this scale is kind of odd because it goes 500 and then 1,000, 1,500. So this first one kind of doesn't really start off the way I would think that it would start off, because this first jump is worth 500 here, but maybe that's just the formatting coming from the actual test booklet into College Board. So let's read the question. The quadratic function graphed above models a particular measure of plant diversity as a function of elevation. According to the model, which of the following is closest to the elevation? So we're looking for elevation in meters in which plant diversity is the greatest. So we need to find out where is plant diversity the greatest and what is the elevation at that point. So plant diversity over here, well, that is the greatest right here, right at that spot. That is the most plant diversity. So we then need to find what is the elevation at that point. Well, for the elevation, we need to go down here at the bottom and right there. So that's where it kind of comes into play, that it's right between 1,000 and 1,500. So I know that 1,250 is between those two. So the correct answer here is C. When analyzing the data, I noticed that across the state, a lot of kids chose the answer A. So if you made a mistake and you actually chose A, I think what you did was you looked at this point, you found the maximum, because normally when you're looking at a parabola, the maximum is there at the peak. But what you answered was the maximum plant diversity, which you're right, it would be 13,500. But the question wasn't asking the maximum plant diversity. It was asking the elevation at the maximum diversity. So just be careful on the reading on that one. All right, number 6, we have a graph of two lines crossing or intersecting, also known as a system of equations. So it says, which of the following systems of equations has the same solution, okay, as the system of equation graphed above? Well, if you are a solution, if I can spell it, solution to a system, well, that is basically the point x comma y of intersection. All right, that is the ordered pair that satisfies both equations at the same time. You know, realize all of these blue points, all of these x comma y's satisfy that equation. And then in red, all of these x comma y's satisfy this other equation. But right here, this green dot right in the center, that's the one that satisfies both of them. And that part right there is located. Remember, this is the x-axis, this is the y-axis. So it looks like we are on the x-axis at 1.5, and we are at a height on the y-axis of 0. So that's what we're looking for, when x is 1.5 and y is 0. Now I look at the answers over there and I don't see any decimals, but I do see a 3/2. So I have to realize that 3/2, or 3 divided by 2, is also the same thing as 1.5. So I kind of have to recognize that. So looking through, it looks like x of 3/2, y of 0 is going to be answer choice A. Now, a lot of kids make a mistake and choose answer B. And basically, they just got the two numbers flipped around. And I don't like this. I think this is just another way the PSAT or SAT tries to trick you. Normally, it's always written x first, y second. And I think a lot of kids didn't really notice that they're putting y first and x second. And that's just another little thing to trip you up, even if you actually know how to do the problem. So really take your time and read through the answers when you're filling out these solutions here. All right, number 7, the function f defined by f of x equals x squared. And just remember, f of x is really just the same thing as y. So this is really saying y equals x squared. Is graphed in the xy plane. The graph of the function g, so a different function, is the graph of f shifted 4 units up. So that's kind of the key part. So we have a function f, which let me just sketch that. You need to know kind of the parent function or the basic function. So if f of x is x squared, then basically what that looks like, it's a parabola. It's a parabola that crosses through at 0, 0. That's where its vertex is. And basically it goes over 1, up 1 on both sides, over 2, up 4. And you could actually go over 3 and up 9, 5, 6, 7, 8, 9. Just kind of sketching it out so you have an idea. And it kind of looks like this. It's like a bowl that basically opens up. That's the parent function. That is what y equals x squared looks like. If you're not sure, you could make a little t-table and you could plug in some values. You know, you put 0 in for x, you get 0. If you put y or 1 in for x, you get 1 squared, which is 1. Put 2 in, 2 squared is 4, 3 squared is 9. And if you go the other way and you put a negative in for x, if you plug negative 1 in, well, that's really y equals negative 1 times itself, which is also 1. If you plug -2 in, it's -2 times itself, which is +4. So you'll see this table here kind of reflect back off of itself. And you'll notice this pivot point right here, this vertex. And then it kind of starts doing the same pattern in both directions. So that's the general idea. This is a transformation problem. So if you look at practice tests from here on out and you notice you're missing these and they're talking about something being shifted, all right, the topic that you want to look at is transformations. I'll be making a video on transformations of different lines and different graphs. Also, Khan Academy has some pretty good practice for transformations. But basically, shifting upward, you need to add a number at the back of the function. So I know the correct answer here is C, because when you do +4 at the back of the function, that's going to move it up 4 units. And if you see the -4, that's going to move it down 4 units. And these things right here, these actually, when it's inside the parentheses, that affects left and right, and it's kind of opposite how you would think. So I'm going to open up Desmos, which is a free online graphing calculator, to kind of show you the difference between those. But this G function that they're talking about here, it said G is shifted up. Basically, we take our parabola and we're going to move it up, and then basically go over 1, 1, over 2, up 4, and then over 3, up 9. And we're going to have the same exact looking thing, just translated or shifted up 4 units. So the key thing is to remember, up is positive and it's at the back of the function. All right, so I've opened up Desmos. It's www.desmos.com, and you just click Start Graphing. And you can create an account or just do it for free. I have an account created. So I'm going to kind of show you the difference. So what I was just talking about, if you type this little keyboard here, it kind of pops up, and you can just use this little math box. But I'm going to type in y equals x squared, just so you can kind of verify and you can kind of see that parabola that I was talking about. Then if I maybe scroll down a little bit or scroll in a little bit, you can see the points I was talking about: over 1, up 1, over 2, up 4, over 3, all the way up here to 9. And then it does the same pattern on both sides. Well, if I want to do a new one, and I want to show you about that moving up 4, I could, and I'm going to just type this one too. I can go y equals x squared, and now I'm going to add 4. I'm just going to do this little +4 here, +4. And I notice my new function, if I zoom in and out, and I'm just scrolling my mouse to zone in and out. But if you notice, it's the same thing. It just shifted up 4 units. Now, if I want to do another one and shift down 4 units, I'll click here, and I'll just go y equals x squared minus 4. And you'll notice that now I have a parabola that just shifted down 4 units. So the plus at the back side and the minus at the back side move it up and down. Now, let me get rid of these and go back to our parent function. To show you left and right, if I put a plus or a minus inside the parentheses, so I go y equals parentheses x, let's just do takeaway 4 parentheses squared. You'll notice my parabola shifted to the right. And you can tell that because if you put 4 in for x, if you substitute 4, you'll get 4 minus 4 is 0. 0 times itself is 0. And you get this ordered pair, 4, 0. The big thing that I always remember is, inside the parentheses, it kind of goes opposite how I would think. I would think minus 4 would go left, because that's where -4 is. But it's the exact opposite of what you would think. Just to verify that +4 is going to move it in the other direction, I'm going to show you that. Y equals x squared. Check that. I got to put some parentheses here. Parentheses. X minus +4. Parentheses squared. And boom, you'll notice it moved to the left. So plus in parentheses moves it left, minus in parentheses moves it right. And if you don't do anything to it, it stays right centered, the vertex at 0, 0. So that might kind of help you out with transformations. All right, number 8, we have a picture there of two lines. It says in the XY plane above, two lines intersect at the origin. Remember that the origin represents 0, 0. So that word origin is just vocabulary for right there at 0, 0. Which of the following pairs of equations could represent these lines where A and B are positive numbers? All right, A and B are positive numbers. Well, I notice both of these lines, they're increasing from left to right. So if a line is increasing from left to right, it's going to have a positive slope. And if a line were to be decreasing from left to right, that's going to have a negative slope. And then there's two other ones. The two kind of freak cases are if you are just going flat or horizontal, you have a slope that equals 0. And if you're a vertical line, you have a slope that is undefined. So looking at these two lines, you know, this blue line is increasing from left to right, so it has a positive slope. This line is also increasing. It's even steeper going up from left to right, so it has a positive slope. And I know that in y equals mx plus b form, this is the slope-intercept form of a line. The m is what represents slope, and the b, or the back number here, represents where you cross the y-axis, or the y-intercept. If you'll notice in this problem, both these lines cross the y-intercept at 0. That's why you do not see any numbers at the back of any of these equations, because it crosses, well, I guess this one shows that it had an intercept, and I know that couldn't happen. So looking through my answers, here are two lines that have positive slopes. You have an A and a B that are both positive, so that's the correct answer. This one, you have a positive slope, A, and then you have a negative slope. So that would be an example of one line going up, one line coming down, which that's not the picture. This one has, this choice right here has both negative slopes. So that would be two lines both going down or both decreasing. It's not that choice. And the bottom one we knew it wasn't because of there was no number for an intercept. So the correct answer here is A. It was pretty much all based on slopes. All right, number 9 can be a little bit tricky here. I know a lot of students typically miss these questions, and back when I used to do a lot of ACT prep, this question is always asked, and basically you're combining like terms. You have some quadratic terms there, you have some linear terms there, but the whole key to this question is this set of parentheses changes everything. And then because they have a minus in front of that parentheses, that's where they kind of screw up most kids. So I'm going to try to walk you through two different ways that I teach people how to do this. Probably the most straightforward way is whenever you see a negative sign in front of parentheses, you want to distribute that negative through. So I'm going to kind of rewrite this. You know, this is 3x squared plus 4x minus 2. And I'm going to be honest, sometimes I rewrite questions so that I have more room. Minus parentheses x squared plus 2x, subtract 1. I know it takes a little bit extra time, and time is very important. However, sometimes I just don't like how the problem's written, and I need to quickly rewrite it to space it out how I like it. So whenever I see minus a parentheses, I put a negative 1 there, and I distribute that negative 1 all the way through everybody. So I copy it down, and I have 3x squared plus a 4x minus 2. This is going to be a minus x squared. It's actually a minus 1x squared, but you really don't need to write the 1. Minus 2x and a positive 1, because a negative 1 times a negative 1 is a positive 1. Now I just have a bunch of terms that I need to gather up my like terms. So to be like terms, you have to have the exact same letters and exponents. So I have a 3x squared and a minus 1x squared. That's going to combine to make 2x squared. Right there, that eliminates a couple choices. And it looks like I need to go further. So I have a positive 4x and a negative 2x. Those add together to make positive 2x. And that pretty much wipes him out, and it looks like A is the answer. I'll go ahead and finish it though. A -2 and a +1 will give me a -1. So that's one way to handle when you're adding and subtracting terms and you have a minus in front of a parentheses. Now, another way that I teach this that some kids like better, a lot of times when you subtract numbers, you stack them on top of each other. So we could do it this way. We could say I have 3x squared plus 4x minus 2. And then look at this as a takeaway, because we're taking away a big old chunk. We're going to take away, and then we're taking away x squared plus 2x minus 1. And some kids just see it better this way. So I'm going to kind of go through and show you this method. So I do 3 subtract 1, which is 2x squared. And then I have +4 take away +2. So that's plus 2x. I got to be careful here. -2 take away -1. -2 take away -1. Well, take away a negative is really add. And that comes out to be a -1. And I'll get the same answer that way. So you could stack them up. I kind of prefer just putting a -1 in front of there and distributing. It's kind of the way I was taught. But either way will work. I notice a lot of my kids, when they do a problem like this, a lot of them will pick the wrong answer here. And I get a lot of people that pick D. And I kind of like, why in the world did they pick D? And what they do is they're kind of combining like terms and ignoring this minus sign. They just kind of ignore that. And then they're like, oh, I have 3x squared and x squared. So that's 4x squared. And then they say, I have a +4x and a +2x. So that's plus 6x. And then they say, oh, I have a -2 and a -1, which makes -3. And then it leads them to believe this is the right answer. And it's all because they ignored that little minus in front of the parentheses there. So just be very aware when you see subtract a big chunk like that. You need to deal with it properly. All right, number 10 follows very similar to number 9. We have a polynomial here, r cubed, r squared. We have r's, we have constants or just numbers. And we're manipulating those. We're adding or subtracting or multiplying or dividing. Well, in this question it says, which of the following expressions is equivalent or is equal to? Keyword here is the sum. Sum means add. Let's just really quickly notice what some keywords are here. So sum always means addition. If they use the word difference, the difference refers to subtraction. If they say the product of two numbers or two things, that's multiply. And if they use the word quotient, it's kind of a weird one, but if they use the word quotient, that means you're going to be dividing. So this problem we're adding, and we're adding two pieces. We're adding r to the third plus 5r squared plus 7. We're adding this chunk or this quantity plus parentheses r squared plus 8r plus 12. Now, unlike number 9, there is no minus sign, so we don't have to worry about distributing a -1. I mean, technically, I guess we're distributing a +1, which really doesn't change anything. So you can almost, when there's no number outside the parentheses and no negative sign, you can pretty much just ignore these parentheses. And now we just need to gather up like terms. So looking through here, remember, like terms have to have the exact same letters and exponents. So I only see one r cubed. So I have r cubed. I see a positive 5r squared. Remember to always include the sign that's in front of the term. So 5r squared plus 1r squared, that's 6r squareds. Looking for r's, I see here I have just one 8r. So he's the only person in the r family. And then I have a +7, +12, which is a +19. And typically we write these in descending order. So you'll notice it goes 3, 2, there's an understood 1 right there, and then 0. So that's called descending order. So final answer, r cubed, 6r squared, 8r plus 19. So that's one strategy of how to solve that. Just like I showed in number 9 though, there's also another way to solve this, and that is to basically stack them up. You know, if you told me, you know, old school without a calculator and said, hey, add up 587 plus 792, I wouldn't add it horizontally. I would add the 792, and I would do it that way because now it's stacked up properly, and I have my ones and my tens and my hundreds columns all stacked up, and it's easier to add. Some people find it easier to add stacking them, so I could have did the first one, the top one, r cubed plus 5r squared. There's no r, so I'm going to leave a space, and then there's the plus 7. So that's this piece. And then I'm going to add, because they said do the sum, I'm going to add the red piece, which didn't have any r to the thirds, but it did have 1r squared, and it did have 8 r's, so I'm going to put this in the blank r spot, and then it did have plus 12. So notice, the only thing with this method is you do have to make sure you have r cubes together, r squareds, r's, and then constants or numbers. And then you can just straight up add them going down. So you have r to the third, 6r squareds, 8r's, and 19. And you'll get the exact same answer that way. Now, whenever I give kids like this a question on the test, I see why they put some of these answers. You know, answers that are good where kids make mistakes, they're called distractors. The SAT is full of really good distractors. And any teacher who writes good tests knows how to use good distractors. But this first one right here is a good distractor because a lot of kids simply try to just say, oh, I'm going to add the first and the first, and they go r to the third plus r squared, which you can't do, but they'll apply the wrong rule and they'll call that r to the fifth. And then they move over to the next one and they say r squared plus r, well, that's 13 r threes, because somehow they think that 2 plus 1 will give them 3. And then they'll add up the 7 and the 12 correctly. And that's where that answer comes from. These aren't just random answers. They know where kids who misapply rules, they know what the answers are going to come out to be. So I would guess the most missed, or the next best answer on here that people picked would be A. So be careful. All right, number 11 is a word problem. According to Moore's law, the number of transistors included on microprocessors doubles every 2 years. So that's kind of I got to pick out the keywords here. The number of transistors, I got to sift out what's important. The number of transistors doubles every 2 years. So that's the key information. In 1985, so starting in 85, a microprocessor was introduced that had 275,000 of these transistors they were talking about. So let me just write that down. In 1985, 275,000 transistors. Well, it says then they double every 2 years. And the final question is, based on the information, in which one of the following years will the transistors reach 1.1 million? So if I'm doubling every 2 years, when do I get to 1.1 million? Well, let's just go 2 years and let's double this. 275 doubled is 550,000. So there's a double. 2 years later, 1989, I get another double, which is 1,100,000, which is equivalent to 1.1 million. So you kind of have to know place value and know that that works out. So not really too tough of a question, not a lot of math, just a double-double. Correct answer here is B. All right, number 12, getting tougher. I see a chart up there with some values. Remember, this is basically just x and f of x is y, so it's just an xy table, a T-chart, some people call it. And I look down at the bottom, and just peeking at my answers, I see that these are all quadratics. And this is very similar to the problem that we did a little bit earlier. I believe it was number 7. So if you go back and you kind of peek at number 7, we talked about transformations. So this is more transformations from graphs, but we have to interpret from a table. So I'm going to kind of plot these points on here and just kind of get an idea of what's going on. I do see this kind of weird pattern where I have a 7 and a 7 both as my y's. So I know it's not linear. It's not, it was decreasing, going down, but then it starts increasing and going back up. So let's just kind of get a little graph here and see what's going on. So and I'm just going to, I guess, do the first quadrant because that's all I have point-wise. And it looks like my x's go 2, 3, and 4. So I'm going to go 1, 2, 3, 4, 5. And then my y's right here go from 5 to 7. So 1, 2, 3, 4, 5, 6, 7. And let's put these points on here. So we have 3, 5, which is right 3 on the x-axis, up 5. So that's going to put me right there. So there's the point 3, 5. I just graph that one. Now I got to do 2, 7. So over 2, up 7. And then I got to go 4, 7. So I have this kind of parabola coming down here. And I got to try to figure out which graph fits that. So a couple things that I need to look at here. The very first thing is I know that the parent function, just plain old y equals x squared, is a bowl that the origin is right there. The vertex is right at the origin. So somehow this thing moved from right here, the bowl part, moved and went all the way up to here. So it looks to me like it moved 3 to the right, and then it moved up 5. 5 up. So remember what I was talking about earlier where, you have y equals, and we have an x, and we have a squared. Well, there's some things that happen to it. When you want to move up, you add a 5 at the back of the equation. So I'm looking over here, and that right there wipes out 2 of these for me. I only see 2 that goes up 5. So just that one piece of knowledge, knowing how it shifted, can get me down to a 50-50, which can be huge. If all the questions that you're not quite sure about, you can get down to a 50-50 guess, I mean, that's a major advantage. You have a really large edge, increasing your odds like that. Now, the other piece to know is that right and left is controlled by parentheses, and 3 to the right is actually the opposite of what you think. It's minus 3. All right? And the square comes out here. So basically, this what's in parentheses just did 3 to the right. This did the up part. And I'll be honest, when I first went through this and I was making my answer key, I thought the answer was A. I mean, I kind of screwed up and just very quickly I was flying through. And I thought the answer was A. And the answer ended up being D. And why it's D is because this number in front here changes the shape of the curve. You can become a really fat parabola, or you can become a really narrow parabola. And I didn't really notice that, but I know on number 7, I talked about the relationship being that the parabolas go over 1, up 1, over 1, up 1, and then they go over 2, up 4, and over 2, up 4, and that's kind of the general look. Well, this one didn't go over 1, up 1. This one went over 1, but then it went up 2. So that should have told me that there's a stretch, there's a vertical stretch by a factor of 2, and that's where this 2 came from. So you got to kind of be careful to see if it does the 1, 1, over 2, up 4, over 3, up 9. If it fulfills that pattern, then you don't have to worry about the number in front of the parentheses. But if something changes, then you need to know that there's a number in front that can tweak it. And I have a content video on transformation of quadratics that kind of go through and break down the 3 different pieces of, the up, down, the left, right, and then whether it stretches or whether it flattens out. Now, that's the technical way. That's the teacher way to solve it. There's a lot of kids that say, whoa, wait a minute, coach. I think I had an easier way to do this. And I'm like, well, how did you do it? And they're like, hey, I just took those numbers and I just plugged them in. I just wanted to see, what was going to work. So you can take these x's and you can just plug them in and see if you get the y value with it. So for instance, I thought it was a, and remember, plug these in and see if it's true. Is it true that 7 equals, because f of x is 7, so I'm putting it in here, 7 equals, parentheses, 2 minus 3 squared plus 5. Plug that in, see if it works. Well, 7 equals a negative 1 times itself plus 5. Well, a negative 1 times itself is 1, and 1 plus 5 does not equal 7. So that would have told me right there that he didn't work. So then I could have moved on, and I could have went to the next one. And I could have went down, and I could have tried, 2 for x and 7 for f of x again, and do 7 equals 2 minus 3 squared plus 9. And that's negative 1 squared plus 9, which is 1 plus 9. Well, that's 10. So this doesn't work. And then I keep on going and keep on going. And like I'll try 2, 7 on this next one. You're going to see something kind of weird happen. So if I try 2, 7 on this one, let me get rid of this. Because here's where they get people this way. They'll say, okay, does 7 equal 2 times 2 minus 2 squared plus 7? Well, you'll look here and it works. You get 2 times 0 squared plus 7. Well, that does work. So you don't want to get all happy and pick that one, though, because not only does 2, 7 have to work, but you also have to then test 3, 5 and see if 3, 5 works in that one. So I redo it, and I say, okay, let's put in 3, 5. 2 times 3 minus 2 squared plus 7. Well, that's 2 times 1 squared plus 7, which 2 times 1 squared is 2 plus 7, and that does not equal 5. When I put 3 in, I was supposed to get 5. Didn't work. So finally, you get down to this last choice, and if you test all 3 of these points, all 3 of these would satisfy and make that equation work. Now again, I think they know this. I think they know questions that you can cheat and plug the answers in. They tend to always pick towards the bottom because they want to really make you eat up a lot of time trying all these ones that don't work. So it definitely would be faster probably on this one if you understood the transformation, but you could plug numbers in too. At the end of the day, it's about getting questions correct. All right, number 13, looks like we have another quadratic because I see that squared. So this is definitely in the advanced algebra part. And it says, what is the smallest value of x that satisfies the equation? Remember, satisfying the equation means you plug x in and it is true. That's what it means to be a solution or satisfies the equation. It all means you plug it in and it equals out what it's supposed to. Now, I've done so many practice tests and so many ACTs and SATs that I kind of know the trick to these. So the absolute fastest way, when it says what is the smallest value of x, that usually means that more than one of these numbers are going to work, but we want to pick the smallest one. I immediately start right at the smallest number and start working my way up. So I'm just going to plug it in. I'm just going to try to cheat this one. 3 times 1, take away 5 squared, plus 11. I'm asking myself, does it equal 59? If it does, then that's the smallest x over there. So I do order of operations. I do parentheses first. And then I got to do exponents. So a negative 4 times itself. This is not the calculator section, but if it was, a lot of kids punch it in like this, and their calculator says negative 16. You can't do that. You have to put parentheses around this. It really means negative 4 times negative 4, which is positive 16. But this isn't the calculator section, so you got to be able to know that in your head. So this is 16 times 3 plus 11, which does come out to be 48 plus 11. Correct answer is 59. The answer is 1. I think there is another number here that works. If I were to go through and I were to try all the numbers and I didn't have the experience to know that more than one x is going to work and I need to find the smallest, most kids just try to plug the top number in and you would get fooled on this one. You would do this and you work that out and you get 3 times 4 squared plus 11, which is also 3 times 16 plus 11, which is also 59. And kids go, yep, it's A. I mean, I guarantee that was probably the wrong answer that was picked the most, because it works, but it was not the smallest. So be careful on that. That's the fastest way. That's the way I would do it. Now, if you went to a hardcore advanced algebra teacher and said, hey, how would you solve this? If you didn't have answers, like if this was a short answer or free response question, it's a little bit tougher. So let's kind of walk through that piece. First thing you'd need to do is you'd need to multiply. This is really 3 times, x minus 5 squared plus 11 equals 59. And I could minus the 11 from both sides. Maybe I minus 11, and I get 3 times x minus 5 squared equals 48. And then I might decide I want to divide both sides by 3 and isolate that parenthesis. And I would have x minus 5 squared equals 16. And then now if I want to get rid of that squared, I can take the square root of both sides. So I could take the square root of this side and the square root of this side. And the square root and the squared cancel each other out. And basically I just end up with x minus 5, which the parentheses aren't really necessary. So I'm going to drop those. And here I got to be kind of careful. This is where 2 answers come in. Technically the square root of 16 is positive or negative 4. Because of that fact that negative 4 times itself is 16 and 4 times itself is 16. The square root's going to be either one. So I'd have to kind of solve 2 cases. And I'd have to say, hey, when is x minus 5 equal to positive 4? And then when is x minus 5 equal to negative 4? And over here I add the 5 to both sides and I get the 9. Over here I add both sides and I get the 1. So I could see I have two answers, and the smallest answer would be x equals 1. So that's a little bit more proper way to solve that problem. There's other ways probably where I could multiply it all out and do some factoring. I don't know if I'll explore that right here. And why not? Some kid out there may have went ahead and wanted to be a glutton for punishment and just do it the long way. But I could also do it this way. And if you already have your answer, just fast forward to the next question you missed. But somebody might have done it this way. They may have interpreted this as 3 times x minus 5 times itself plus 11 equals 59. And then you would probably use FOIL or double distribution here. And you go x times x, which is x squared, x times a negative 5, which is negative 5x. Then you do this term by both pieces. That's another negative 5x. And negative 5 times negative 5 is positive 25. So that is what those 2 times together would be. Then you'd have to multiply by 3. Then you'd have to add 11 and get 59. Whew! It's already looking like a lot of work. This would be 3x squared, combine some like terms, plus 11. Let's go ahead and move that 11 over to the other side. And let's just put equals 48. All right, so what I'm going to do is I'm just going to minus that 11 right now, put him over there. And then I might multiply the 3 through, and I get 3x squared minus 30x plus 75 equals 48. Oh man, this is looking ugly. And then I'm going to come through, and right now my move at this point would be, I recognize that all of these pieces are divisible by 3, so I would probably divide the entire equation by 3, both sides, to kind of shrink it down further. But maybe before I do that, whenever you solve a quadratic, you're supposed to get one side equal to 0. So let's just minus 48 from both sides. You know, I would never do this problem this way, but I'm just kind of doing it in case somebody went down this road. And positive 75 and a negative 48, that's what, 27 equals 0. And I'd really love to have just a 1 in front of the x squared. It's way easier to factor. So right now I would divide everybody by 3. Divide every term by 3, which doesn't hurt anything. And I end up with this. Well, now I got a couple options. I can either use a quadratic formula, which I'm never going to want to do if I don't have to, or I can factor. And I think on this one I can factor. I need to find two numbers, and I have a content video on factoring quadratics. Whenever you do these, you want to find two numbers that multiply to make positive 9 and add to make negative 10. So multiplying to make positive 9, my choices are, 1 and 9, negative 1 and negative 9. So they multiply to make 9. And also 3 and 3, or negative 3 and negative 3. Those are the only combinations that multiply to make positive 9. Well, out of all these, the only ones that add to make negative 10 are right here. So I have x minus 1 and x minus 9. And now I use something called the zero product property. I call it ZPP, zero product property. And basically it says if something times something equals 0, one of those two parentheses are 0. This parenthesis is 0 when x equals 1. And this parenthesis is 0 when x equals 9. So now I get my two solutions, and 1 is the smaller solution. Whew, I would never do it that way. All right, so number 14, looks like we have a system of equations. So if you're analyzing why you miss problems, this is definitely a system of equations. And actually, usually they're both lines. This one right here is not linear. If you were to graph that, it's not going to be a straight line. There's a lot of combinations of two numbers. Basically x times y equals 72 says, hey, what are two numbers that times together to make 72? And there's a lot of them. You could have 1 and 72, 2 and 36, 3, let's just keep going. 3 goes in there 24 times. 4 goes in there, looks like 18. 5 doesn't go in there. 6 times 12 works. 7 doesn't go in there. And 8 times 9. And then you kind of start repeating yourself. So these are all the numbers that multiply to make 72. And you could kind of look at those as ordered pairs. And they definitely would not make a straight line if you graphed all those ordered pairs. So, the easiest way to tackle this problem is it's basically saying find two numbers that add to equal 17, and the same two numbers have to multiply to equal 72. Well, I think most of you could probably come up with this, in your head. The two numbers that do that are right here, 8 and 9. So there's a combination of x and y that would satisfy that equation. And then also you could flip them. You could go 9 and 8, and that would still work. So it says, what is one possible value? So that kind of lets you know that there's more than one right answer. So it looks like either one of these could work. So an answer of 8 or 9 would work here. That's the fastest, easiest way there is. Just if you could literally translate these two equations into a word sentence and find the right combination of numbers. Now again, a hardcore advanced algebra teacher, if they're teaching this unit, they probably would not solve it that way. They would probably use substitution here. So substitution kind of works like this, and I have content videos on elimination, substitution, graphing. But substitution, you want to try to get one equation solved for a letter. So for instance, I don't know, maybe I'm looking at this thing and I want to get, maybe I'll get y by itself. So in this top equation, maybe I minus x from both sides, and I end up with y equals 17, take away x. I just kind of moved the x to the other side. Well, then I have this x times y equals 72. Well, I now can get rid of y because I know what y equals. So since I know y equals this, I'm just going to substitute it right here. So I'll have x times the new y, which is 72. And now I got to solve this, which is going to give me 17x minus x squared equals 72. Well, this is kind of nasty because I have x and I have x squared. I can't combine them. I can't get x by itself. So this is basically a quadratic, and I want to set the quadratic equal to 0. And I'd really like x squared to be positive. So I'm going to move everything to the right-hand side. So I'm going to take away this 17x, and I'm going to add x squared. So I have to do it the other side. Take away 17x, add x squared. And now I'm going to have 0, because all this cancels. And I'm going to rewrite it because I want it in descending order. I'm going to put the x squared first, the minus 17x second, and the positive 72 third. And now to solve a quadratic, you normally try to factor. So I'm going to factor. And basically what we're doing here is we're finding two numbers that can multiply to make positive 72, but can add to make negative 17. So immediately I'm thinking 8 and 9, negative 8 and negative 9, they multiply to make positive 72. They add to make negative 17. So I go x minus 8 times x minus 9 equals 0. And I'm going to use the zero product property like I did in the last problem, the way that I wouldn't have done it. And basically this first parenthesis equals 0 when x equals 8. And the second parenthesis, so either x had to be 8 or x had to be 9. One of those two parentheses had to be 0 for this to happen. So there are my two answers. And it's the same thing I got, but just a lot more work. So since time is of the essence, I would have definitely did it strategy number 1. All right, number 15, we have some division going on here. If blah, blah, blah equals 24, what is the value of 6x? So this one's kind of weird. Normally they say, what is the value of x? They're saying, what is the value of 6x? So a couple different things. I may want to find out what x is, then multiply by 6, maybe try to figure out what x is and then times by 6. Or in this case, I'm going to get lucky, and then I'm going to show you a little trick where you don't even have to find x. We can actually find 6x. So let's check out this problem. I have 3x plus 3x, all divided by 6, equals 24. Well, I see right away I can combine like terms on the top. 3x plus 3x is really 6x divided by 6 equals 24. So all I did was I just combined these two like terms. Now, most people right now would probably go this direction, and I wouldn't do this because the answer is a little faster. Maybe I'll show you the fast way. Right now, notice this is what I want. I want to know what 6x equals. So to get 6x by itself, I just do the opposite of divide by 6. I just times this side by 6, which cancels these out, times this side by 6, and what I'm left with is 6x equals, what's that, 120 plus 24, 144. And that's what they wanted. They wanted to know what 6x equals. What equals 144? That's the answer to the question. Now, most people wouldn't have did it that way. a lot of people would have said, well, I'm going to combine like terms, and I'll get 6x over 6 equals 24. And then they would probably cancel out these 6's, which is fine. And you get x equals 24. But then you got to go back and figure out, well, what is 6x? You're just basically now having to times 24 by 6 again. Times both sides by 6. And you'll find out that 6x equals 144. So, it wasn't a huge waste of time, but you kind of chased your tail by dividing by 6 and then having to multiply by 6 again. But correct answer is 144. All right, number 16. According to a model, the head width in millimeters of a worker bumblebee can be estimated by adding 0.6 to 4 times the body weight of the bee. All right, I'm not going to go any further. Right there, I need to translate and write up an equation. So the head width, all right, so let's just say that. The head width can be estimated by adding, so the head width is, I add 0.6, so I add 0.6 to, or add it to what? It looks like I add it to 4 times the body weight. So if I go 4 times the body weight, and then add 0.6, that will give me the head width. So I think I have a pretty good equation going on there. According to the model, what would be the head width? So this is what we're trying to find. What would be the head width? And hopefully they give me the body weight here. Of a worker bumblebee that has a body weight of 0.5. So they're telling me what the body weight is. So I go 4 times the body weight plus 0.6, and 4 times a half, well, that's 2, and 2 plus 0.6 is 2.6. Now, that didn't seem that difficult for towards the end of the no calculator, so I'm a little nervous, so I might go back. I might just reread it. I might also check units, because I noticed, they were talking about millimeters and grams, and sometimes they switch on you and you need to convert, but they wanted the head width in millimeters, so I'm talking millimeters. The body weight was in grams, and then they asked for the head weight in millimeters, and they give me the body weight in grams, so I think I'm good to go. There was nothing that needed to be converted there, so I feel pretty good. 2.6. All right, last one on the no calculator, free response, number 17. I get excited when I see geometry because I teach geometry 3 blocks out of the day, and there aren't very many geometry problems on the SAT, so I kind of get excited when I see one. One thing to note here is that it says the figure is not, move that picture around. It says the figure is not drawn to scale, so that means it may look bigger or smaller than it really is, so you can't really just guess at the dimensions. So it says the area of a triangle above is at least 48. So area is at least 48, but no more than 60. So that's my first clue. The area is somewhere between 48 and 60. And then it says if y is an integer. So remember, integer is either a positive or a negative whole number. So aka no fractions, no decimals. What is one possible value of x? So they didn't say anything about x. They just said y has to be an integer. They didn't really say that x had to be an integer. So x might end up being a fraction or a decimal. All right, so I have those clues. Well, first thing I need to know is I need to know the area formula for a triangle. Now, if you go on the front of the test, there is a reference sheet, and they do give you this information. Hopefully you have it memorized. But the area for any triangle is 1/2 base times height. All right, 1/2 base times height. And for a right triangle, it's kind of easy, because if you're a right triangle like this, basically the base is this bottom piece, and the height is how tall it is on the side. And in any triangle, the base and the height have to interact or meet each other at a right angle. Otherwise, they're not truly a base or a height. So in this problem, since they give me these bottom numbers, they told me that I have 5 and I have 7 for a grand total of 12. So I'm going to plug 12 in for my base. So the area is 1/2 of 12 times the height. And in this problem, they're calling the height y. So instead of putting an h, I'm going to put a y in there. And then they told me what the areas could be. They told me some possibilities of what the area could be. The area could be 48 through 60. So let me just kind of figure out that range there. So let's see if the area is 48. Well, I'm going to come down here where I have a little bit more room. If the area, so the area is 48, 1/2, my base is 12. What would y have to be for the small end? Well, when I calculate this out, I get 48 equals 6y. Divide both sides by 6. I find out that y equals 8 could be a possibility. But that's not what they want. They don't want y. They want a value of x. So x is kind of this little piece right over here. So that 8's not my answer yet. And then also, it says that it could be as big as 60. So let's just kind of take that into account. What if the area was 60? Well, that's 1/2 base times height. So 60 is 6y. And when I divide both sides by 6, I get y equals 10. All right, so on the low end, y is 8. On the big end, y is 10. But it says it could be between those numbers. It could be anything between 48 and 60. So anything in here. Now, it did say y had to be a whole number. So since I have y equals 8 and y equals 10, it looks like y equals 9 could also be a possibility. And if I check that out, if I put a 9 in there, I would have 1/2 times 12 times 9, which would be 6 times 9, which would be 54 for the area. So these are the possible areas, 48, 54, and 60. Well, now, how do I find x? So I think I need to erase some of this stuff here, but the key part that I'm going to keep is that what y could be. Y can be 8, 9, or 10. So I'm going to write that up here. Y is either 8, 9, or 10. And then I'm going to get rid of some stuff just so we have some room to work and it's not so cluttered looking. So now that I've established what y possibly is, I need to focus now on these triangles that are actually similar triangles. I kind of have a small triangle. Let me just draw this little one here. I have a small triangle that's 5 by x. And if I compare that to the big triangle, and let's just do this first one using the value, we know 12's there. Well, let's use this one. Let's use y equals 8 first. So I have a proportion, and these two triangles are similar. Because they're similar, and I know that they are, because anytime that you have two lines that are parallel here, and they're both right angles, they're 90 degrees, so they have to be parallel. Anytime you have that going on, it's going to create two similar triangles, like a small version and a bigger version. And we can set up some things. So let's set up some corresponding sides. So here's a proportion. I'm going to set up 5 is to 12. So base, little base is to big base, as little height is to big height. And when I work this one out and I cross multiply, that's how you solve proportions, I get 12x equals 40. And if I had a calculator, I might punch that in and get an answer, but I don't have a calculator. So I'm going to just divide by 12, divide by 12. On the SAT, you can do decimals or fractions. I prefer to leave them as fractions and just reduce them down. I think it's easier. I'm not going to mess around doing long division by hand. So let's reduce this down. I could start off, I see that 2 goes into both these numbers, so I could maybe shrink it to 20 over 6. And 2 goes into both those numbers again. So I think that 10/3 is a possibility. Now you could also put in 3.3, repeating. I think this is a gridded response. So basically what you can do is you can go 3.33 and then you'd have all 4 grids bubbled in. But 10/3 is safer. You can just grid in 1, 0, /3 and that'll represent your answer when you're doing the bubbles. Well, we only took care of this possibility. Now we need to kind of change it and say, well, what if this is a 9? Because we established that 9 could give me the right area too. So same setup, little base, big base, little height, big height, and you can cross multiply and get 12x equals 45. And divide both sides by 12, and you'll get x equals 45 over 12. And we need to reduce that down because I don't think there are 5 slots to grid. I think there's only 4. So looking at these, 3 goes into both those numbers. 3 goes into 45 15 times, and 3 goes into 12 4 times. So there would be a correct answer. I don't think we can whittle that down any further. 15 over 4. If you want to do the decimal, I wouldn't because it's just another chance for a mistake. But 4 goes into 15 3 times with 3 left over. So 3 3/4 would be 3.75. But you're kind of risking it there by doing extra math in your head that you don't really need to do. And then finally, if I change this back number to a 10, and you didn't have to do all these. You could have picked any one of these because it just says what is 1 possible. But if I change it over, I'll get little base over big base equals little height over big height. Again, cross multiply. 12x is 50. Divide by 12, divide by 12. X equals 50 over 12, I can whittle that down. That would be 25 over 6, which is as low as you can go. So you could grid in 25/6, or if you prefer decimals, 6 goes in there 4 times with 1 left over. So 4 1/6, which you cannot grid that in, but that comes out to be 4.16 repeating. And I believe that's all the decimals you'll get. But the 1/6 repeating, you do have to be careful because that would round to 4.17. And I'm pretty sure that they don't make you round. They allow you to just keep the first 4 decimals and just truncate it or just cut it off. So I think either of these would be acceptable. But why get into that? Just grid in that fraction and be done with it. All right, so hopefully this video helps you out, helps you kind of see what you did wrong on some problems, and you'll be ready to take it to the next level when you start doing the official practice tests that are a little bit longer and involve a little bit more content that they think that you'll have by the end of your junior year.